Right, time for lesson 5, Conditionals Explore. So as a intro to this, to get you thinking, imagine that you want to make a decision about what to wear to an event. And you need to think about two pieces of information you would want to have in order to make a decision on what to wear. Let's think about that for a second. It could mean that you would like to know the formality of the event. Is this a special occasion? Is it a casual event? And that would factor into your choice. Or it could be weather. Is it going to be cold, warm, raining? Things like that. Or you might have thought of something else. And as we go into thinking of conditionals, this kind of thinking and decision making based on information that comes into the decision is what it's all about. So we're going to be doing an activity in class, but I'll just do it digitally here in case you missed the class lesson. We're going to be working with baggies and Post-its again. So as a recap, information can be stored as numbers or strings. Those are the values that we have previously stored inside variables that we use baggies to represent. But information now can be stored a third way. It can be stored as a Boolean. We call that a Boolean, named after George Boole. And a Boolean piece of information is just going to be true or false. So we're going to represent that here in a blue sticky note. So in this case, we have an expression. And we have a less than sign. So it's not a plus, it's not a minus, it's not something that we can evaluate to be a number. In this instance, we are trying to evaluate whether this evaluates to true or false. So we say 3 less than 8, is that true or false? And that is true. So this is known as a comparison operator, and we have several of those. You've seen them in math before, less than, greater than, and we represent it a little bit differently, less than or equal to, greater than or equal to, and if we want to say that it's equal to, we actually have to use two equal signs, and we could also say not equal to. So if you put any of these comparison operators in between two values, then you are asking the computer to tell whether that is true or false. Um, and so this is showing you a little bit more of a complex expression. We have 3 plus 6 less than 8. So whatever is on this side of the comparison operator has to be reduced first, just like in math, before we can compare it to what's on the other side. So this is reduced to 9, and this is still 8. So 9 less than 8, is that true or false? And that one is false. So we have a few other examples here. Do these in your head and see if you're right. Make sure that you're reducing the items on either side of the comparison operator to a single value first before we would compare it to the other side. Okay, so these would be reduced to 3 less than 5, true or false? True. 2 greater than 3, true or false? False. 12. Oops, there we go. So all that was 12. Less than or equal to 10, false. 14 equal to 14, true or false? True. So that's how this works. Any values that are in a variable can also be used in an expression by just using the name of the variable. If we just say lives plus 4, we're referring to the value that is being stored in that variable called lives. And same with score. What is the current score? 10. What is the current lives? 5. So we would add the two together on either side, 9 less than 9, and that would be false. Any expression that can be evaluated for true or false is called a Boolean expression. So we use that term a lot more. You'll get used to it, but anytime you hear the word Boolean, know that we're trying to figure out if something is true or false. So here is an example decision. Can I go to the movies? I'm allowed to if it's before 8 o'clock. So in this case, what do you need to know? You need to know what time it is. So we can create, create a baggie to store that information. We could call that time, and then we could indicate what is the current time, and then we could evaluate this Boolean expression to see if can I go to the movies is true or false. So here's how it looks in a flowchart, and we use these flowcharts as a way to visually represent what's going on in the Boolean expression. It's helpful to some people, it's not helpful to some people. Sometimes it makes it more confusing, but just I'll walk you through it, and then if you decide not to use it in your own lives, that's fine. So we would write the name or we would write the problem, I guess you would call it, at the top. And then we indicate what variables we have to have in order to solve this problem. In this case, it's time. Once we know the time, we go into the Boolean expression, time less than 8. So if time is less than 8 is true, then we can go to the movies. If time is less than 8 is false, you can't go to the movies. So an example, it's 9 o'clock. So 9 goes here in our variable time, and then we move into the Boolean expression, and we move 9 in place of time. So 9 less than 8, is that true or is that false? It's false, so we can't go to the movies. Here's another one. Have I won the game? I have if my score times my lives is greater than 10. What information are we going to need to know? So in this case, we will need to know two pieces of information. We need to know our score and we need to know our lives. And then we can evaluate whether those multiplied together is greater than 10. Kind of like a math word problem here. I'm sorry if you hate those, but again, we'll try to walk through it. So we put our problem up here at the top. Having won the game, I have if my score times my lives is greater than 10. So in this case, we need two baggies, score and lives. Once we know those two pieces of information, we move into the Boolean expression. So we can multiply them together and see if they are greater than 10. If that's true, you won. If that's false, you haven't won yet. So we're going to test it in a few different ways. Test 1, score is 3, lives is 3. So 3, 3, 3, 3. 3 times 3 is 9. Is that greater than 10? No. Test number 2, score is 1, lives is 10. 1, 10. 1 times 10 is 10. Is that greater than 10? Still no. Test 3, -5 and 2. -5, 2, -5, 2. -5 times 2 would be -10. Is that greater than 10? No. So all of these were false. And here is a challenge for you. Is my dog older than me if his age is converted to human years? There we go. 7 dog years equals 1 human year. So what piece of information would we need to know here? We need to know his age, and we need to know our age. So there's going to be there we go. There's going to be two variables in this case, the dog's age and my age. Once we know the dog's age, we'll have to multiply it by 7. 7 dog years equals 1 human year. And if that is greater than my age, then the dog is older than me. So you could play with that and just put in some sample numbers, pieces of information to see if you get the results you were expecting. What if your decision requires several steps? So here's an example. Can I adopt a cat? I can if I have $40 and I am over 14 years old. So in this case, we're going to need to compare two different things to evaluate whether they're true or false. We have to have $40 and we have to be over 14. So what information would we need to know? Again, we need to know how much money we have. and we need to know how old we are. So here's what that might look like. And I had to move this over because because it looks a little more complicated, but the basic setup is the same. We determine, okay, we need two variables. We need to know how much money we have, and we need to know our age. Once we know those pieces of information, we'll go into the first Boolean expression of evaluating our age. And in this case, it really doesn't matter which one you do first, whether you do money or age, but in this case, I just started with age. So if my age is over than 14, if that's true, I can move into the next decision. But if I am not over 14, it's false, and automatically I'm out of it. I cannot adopt a cat. So let's assume that our age is over 14. That's true. So we move into the next Boolean expression to evaluate whether our money is equal to 40. And notice that this says I have $40. It doesn't say I have 40 or more dollars, more than $40, at least $40. It doesn't say that. So we have to be very specific in our language, and we have to tell it money has to be equal to $40. So the only way this is going to be true is if the money is exactly 40. So let's assume it is, and that's true. We can adopt a cat. But if it is not exactly 40, we're out of it again, and we cannot adopt a cat. Oh, here's an example. I'm 17 years old and I have $39. You can already kind of predict what's going to happen. I'm 17, so that one evaluates to true. Then I go here, 39 is not equal to 40, so I'm out of it. So Boolean values are a type of information, the true or the false. That's a value, a Boolean value. They can also be evaluated in a Boolean expression using logical operators, and that's these three things, and, or not. So if we have true and false, that would be false. If something is true and false, it evaluates to false. Um, excuse me, let's look at some more examples to make that make more sense. We have something called a truth table, and it looks like this. So you've got basically, if you encounter these two values and they are tied together with an and operator, here's what they will evaluate to. So hopefully this makes more sense. If one thing is true and another thing is true, and they both have to be true because you said and, then that means that the whole expression is true. All right. Then you have if one thing is true and another thing is false, and you're saying it has to be true and true for the thing to happen. So think about the age and the money. If one is true but the other is false, then it evaluates to false. If one is false and the other is true, it evaluates to false. So the only way in any of these scenarios for true to come out of that complex Boolean expression is if both things are true. If both things are false, obviously the whole thing is false. Okay, here's an or truth table. So if I want to say I have $40 or I'm over 14, then how would those evaluate? In that case, only one or the other has to be true in order for it to evaluate to true. If both things are true, that's great. But if neither thing is true, that's the only time when this would be false. So I do not have enough money and I am not old enough. That's going to be false. And then the not is very simple. If it's not true, it's false. If it's not false, it's true. We'll get some more experience at these and they will make a little more sense. So here's how we would simplify that flow chart about the cat. We would just say, here's our first expression. Money has to be equal to 40. Is money equal to 40? And then we could tie it together with an and we do use two ampersand signs to indicate and. age is greater than 14. So this way we can write it all in one line, and the computer knows how to handle that. So let's try it out. I'm 15 and I have $40. 40 equals 40. 15 greater than 14. And both have to be true for us to be able to adopt a cat. That side is true. That side is true. So the whole thing is true, and I can adopt a cat. Um, in class, I would have you make your own flowchart here, thinking about that decision that we talked about earlier about how to decide what to wear to an event. So if you're not in class, just obviously you don't have to do that. But key takeaways from this lesson: Boolean value is a data type that's either true or false. Comparison operators, if you see those, you know you're working with a Boolean expression. If you're comparing two things, the computer's not going to solve the problem. They're only going to tell you if it's true or false. And then you've got your logical operators, is a new thing. So anytime you see those, often also indicates that it's a Boolean expression. And each side, you have to evaluate both of these and then evaluate the whole thing together in order to move forward. And I have a video that you'll need to watch that's posted on Google Classroom assignment. And I believe that's it for today.